Welcome back to another episode of Straight Fire. In this episode we'll be talking about parallel lines, the vocabulary surrounding the angles with those lines, and we'll be using algebra and a few of these questions as well. Now, just to make sure you're doing this video, working this video correctly, make sure that you've tried to answer these questions first without any help before playing the solutions to the video. Alright, now that you've actually attempted the questions and gave it your best shot, check your answers over and see if this helps. So you can see that in the picture over here I've actually color-coded the corresponding angles. 1 and 8 are in the matching position. That's what corresponding means. And then the other corresponding angles would be 2 and 5, the yellow ones, 4 and 7, the red ones, and 3 and 6, the blue. For question B, they're asking us for the alternate interior angles. Well, interior means the inside, and alternate means one on one side, one on the other side, or the word alternating. So the alternate interior angles are 3 and 8 and 4 and 5. Think about it. Do you think 3 and 8 are the same size? Both of them are obtuse angles, and yes, both of them are equal to each other or congruent to each other. And look at 4 and 5. Both of those are acute angles, and those are also congruent. So in this picture there are a lot of angles that are the same. 2 and 4 are the same. Do you remember the vocabulary words for that? That is a set of vertical angles. Those are the same. 2 and 5 are the same because they are, what is the vocabulary word that is associated with those two angles? Those are the corresponding angles. And 4 and 5 are equal because they are alternate interior angles. So that's what you'll see in this section quite a bit. For question C, naming the two pairs of consecutive angles or consecutive inside angles or interior angles. The consecutive angles are the angles that appear one right after the other. And in this picture right here, the consecutive interior angles are 3 and 5 and 4 and 8. And then a quick check on your math here. Angle 3 and angle 5, are they the same or are they different sizes? Well, 5 is an acute angle, 3 appears to be an obtuse angle, so there's no way that they could actually be equal to each other. But if these two lines are parallel, then these two angles will add up to 180 degrees. Another fact that gets used. Alright, question number 2, you can see that I've actually started the solution there. I've matched up the corresponding angles with each other and then found the matching vertical angles. And then it's all remaining to do is find the other angles that are there, and to figure that out you should think about this as being a straight line worth 180 degrees altogether. So these are linear angles, angle 1 and the 154. So this angle would have to be 26 degrees to make that 180 degrees combined. And if that is 26 degrees for angle 1, then this is also 26 degrees for angle 3. Angle 1 and angle 4 are corresponding, so those must be 26 as well. And if 4 is 26, then angle 7 has to be 26 because those are vertical angles that must be equal. Okay, moving to question 3. We're after the angle there in the corner, angle T, and to get that, they're not telling me in the directions that these are parallel lines. So that's actually necessary to solve the question. And let me emphasize that. It doesn't say that they're parallel, and it should say that PQ is parallel to ST. Without that piece of information, you're unable to solve the question. Alright, now that they're parallel, we know that these alternate interior angles must be the same, so that's 40 degrees. Well, I'm not after angle S, But that's not my end game. My end game is to figure out what angle T is worth. So if I could figure out what angle SRT is worth, I know that all three angles add up to 180 degrees, then I'll be able to figure out this angle, angle T. So to unlock this mystery, I'm noticing that these two angles here are a linear pair. They add up to 180 degrees. So angle X plus 50 must add up to 180 degrees. So if I solve that very small equation by combining like terms and subtracting 50 from both sides, I find very quickly that 2x has to be worth 130 degrees. Dividing both sides by 2 tells me that x is worth 65 degrees. So going back to the picture, I know that this is 65 degrees here, and one way to figure out angle T is to figure out angle SRT first. And SRT is 50 plus the 65, so it'd be 115 degrees. And then all three of these angles must add up to 180 degrees. So far I have 115 and 40. That's 155 degrees for just those two angles together. So add these two angles together, that's 155 degrees. That's what I have so far. What I need is 180 degrees total. So subtract the two from each other, and I find out that this angle is worth 25 degrees, angle T. There's a shortcut to figure out angle T as well, which does not even involve using the 115. Maybe it's something you've learned already, or maybe it's something you can just notice right here. So this exterior angle, 65 degrees, is equal to the sum of the two remote interior angles. So if that's 65 and I know that that's 40, then this would have to be 25, because these two angles here add up to be the angle that's outside or on the exterior of that triangle. Okay, moving on to the last question. There are several ways to work this out, but to begin to solve it, the thing you have to realize first of all is that these arrows mean that these diagonal lines are parallel to each other, and these double arrows here in red are telling me that these horizontal lines are parallel to each other. Definitely necessary to be able to solve this question. So there's a few ways you can attack the question. You could find angle Y first. You could find angle Z first, or angle X. In this case, there's three ways to begin. Let's start by finding angle X. Well, I've got 106 degrees here in the picture. With your knowledge of the vocabulary, find the corresponding angle that goes along with 106. So you should be thinking about this angle over here as 106 degrees, because that is the corresponding angle. Well, take another look at that picture. Is there any other angle that would be corresponding with this 106? Do you think you see it? Do you recognize it? Which one's corresponding to this 106? It would be this angle here as well. That would be worth 106. Which seems like it's off target, like we won't need that. But if you're thinking about an angle that is corresponding to this 106, you could also say that it's this angle here. So that's how we're going to solve for Z, is knowing that this is 106, so this is 106. And of course you could have gotten it from this information as well. That's 106 there, that corresponds with this. This 106 corresponds with this, which is also 106. Well, I'm getting ahead of myself. So plopping down that 106 in the picture is a good way to begin, and then I can quickly find out what angle X is worth. X would have to be worth 74 degrees, because that is a linear angle with 106 degrees. That makes 180 degrees total. If angle X is worth 74, then I know that angle Y is also worth, or 2Y is also worth 74 because of corresponding angles. So that 2Y there is the same as 74 degrees. Dividing by 2 can help me find out what Y is worth. So Y is worth 37 degrees. So I've figured out what X is worth, and I figured out what Y is worth. The last bit is to figure out what Z is worth, and that's where the 106 comes to play. So the 4Z plus 6 equals 106 is how to begin that. Subtracting the 6 tells me that 4Z is worth 100, and dividing by 4 tells me that Z must be worth 25 degrees. And that wraps up another episode. So keep on working really hard and have a glorious day.